Welcome to Truth Projects. In this video, we are going to explain about index page of the application. Introduction. An extensive web application for crawling, indexing and searching web information is the subject of the project being discussed. To collect information from websites, it uses a depth-limited BFS crawling technique. The crawl data is stored to prevent repeated crawls using the Python Beautiful Soup package. The created inverted text improves the effectiveness of text retrieval. The program provides a user-friendly interface for doing searches using text queries or URLs, and it returns pertinent results with information about professors and study areas. This adaptable system simplifies information retrieval and analysis, making it a useful tool for scholarly investigation and discovery. Objective. The project's objective is to create a full web application with search engine and information retrieval features. In order to extract information from specific websites and create an inverted index for effective search operations, the application uses crawling techniques. Users can choose search options and enter text queries or URLs to receive pertinent data. The initiative intends to improve access to valuable resources by facilitating efficient information retrieval, allowing users to investigate study areas, professors, and their work. Strong crawling, indexing, and search features in the application offer a user-friendly interface for quick access to pertinent academic literature, facilitating the easy finding of research subjects and related subject matter experts. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirement, we have operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 50 GB and above. Software requirements. In software requirements, we have Python 3.7.0 version and MySQL Workbench. Methodology. To implement this project, we have designed the following modules. The first module is crawl page. The crawl page module is responsible for scanning and collecting data from web pages across the internet. This process is often referred to as web crawling or web scraping. The module's task is to visit different web pages, follow links, and retrieve the content from those pages. The crawl data could include text, images, links, and other relevant information. The purpose of this module is to gather a wide range of content that can later be indexed and searched within the application. Second module is load pages and generate inverted index. After the crawl page module collects data from various web pages, the load pages and generated inverted index module comes into play. This module involves two main steps. First one is load pages and the second one is generate inverted index. Load pages. The data collected during the crawling process needs to be stored and organized in a way that makes it easy to search and retrieve later. This module involves passing and storing the content of the crawled pages, including the textual content and metadata such as URL, timestamp, and other relevant information. Generate inverted index. An inverted index is a data structure commonly used in search engines to optimize text retrieval. It involves creating a mapping between words and the documents or pages that contain those words. For each word, the index stores a list of documents where the word appears. This allows for efficient and fast retrieval of documents containing specific words during searches. And the third module is search engine text retrieval. The search engine text retrieval module is the core of the application's functionality. It's responsible for taking user queries and returning relevant results from the indexed data. This module involves several key steps: query processing, matching, ranking, presentation. Query processing. The user's query is passed and analyzed to extract the relevant keywords and terms. Matching. The extracted keywords are used to search the inverted index. The index is consulted to identify documents that match the keywords. This involves looking up the keywords in the index and retrieving the list of documents associated with those keywords. Ranking. Once the matching documents are identified, they are ranked in terms of relevance to the query. Various algorithms and criteria can be used to determine the order in which results are presented to the user. Presentation. The ranked results are presented to the user, often in the form of a list of links or snippets of text. The user can then click on the links or snippets to access the full content of the corresponding documents. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the index folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project code during runtime. This is the index app folder. It contains all the template and static folders. Template. This folder contains all the HTML pages used in the project. It typically includes files like index.html, home.html, etc., which represent different pages of the website. Static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is manage.py. Manage.py is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is run.bat file. Instead of executing the program in the command line interface, we created Windows bat file to execute the project. Double click on run.bat file so that manage.py file is compiled. After running the manage.py file, the Django framework will host the application locally at the default address and port. Copy the local link. I'm copying the link and paste it into any web browser and type index.html at the end and hit enter. I prefer Google Chrome. This is the front end developed by Django framework. The home page of the project is displayed in the browser, and in the home page we have crawl pages, load pages in generated inverted index, search engine, text retrieval. Now click on crawl pages and enter the crawl URL. So we are entering the URL of the profiles from the Google Scholar. Copy the URL and paste it in the crawl URL. And click on start crawling. In above screen, entered page URL to start BFS, breadth first search crawling, and here I gave depth as 5. And if we give huge crawling, then Google is banning our IP address by saying too many request errors, and then we are unable to crawl. So we have started the crawling. So here in the black console, we can see application start crawling using Python Beautiful Soup. After crawling, then all pages data will be saved inside file and we can directly load from that file and for next time processing. By using this file saving operation, we are not supposed to crawl again and again and not need to add robot also, as we can crawl anytime by giving input URL and pressing button. Crawling may take long time also, and we can monitor crawl pages from black console. So here we can see that crawling is completed. Now click on load pages and generated inverted index to load pages and then generated inverted index from the crawled pages. So here we can see that index generation process is completed. In above screen we can see index generation completed, and now click on search engine text retrieval. So this is the crawling screen. Now search the query. We will search type here is search by URL. So we will copy the URL. And paste it in the search query and click on submit. So here we got the search result, in which we have the professor ID, professor name, university details, email ID, city count, research title, relevance count, research title page, and professor home page. So if we want the research title page, click here. So here we can see we got the research title page. And now if we want the home page, professor home page, click here. So we can see we got the home page of the professor. and we can see all the details related to the professor. So in this way, just by clicking here, we can get the research title page and the home page. And the conclusion of the project is, the application's index page displays a thorough search and retrieval system. The application effectively collects web data using BFS crawling and Python's beautiful soup, creating an inverted index to speed up subsequent queries. This project provides an easy-to-use interface for querying text and URLs, delivering results that are pertinent to the research fields and topics. It allows visitors to discover deeper insights by navigating between professor and research pages without any noticeable delays. The project improves information discovery thanks to its proficient indexing and retrieval algorithms. It gives users the ability to quickly access relevant research and academic data, which promotes effective knowledge acquisition and exploration. Thank you for watching the video.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.